We're doing space weather, and if you failed to see our short video last night about this particular filament on the northeast corner of the sun, let's revisit it. There you have it, 171 angstroms. Check it out. Crazy magnetic filament dancing around. Coronal holes were still rotating in. We've got some geomagnetic storms predicted. First, let's look at the sun and some other wavelengths. 304 angstroms. And 193 angstroms. To look at the current state of that coronal hole. Which is having a seemingly absent magnetic connection here. Not sure what's going on with that. Doesn't make a whole lot of sense. Let's look at the magnetic lines. The sun's magnetic lines currently look like a bad hairdo. Let's look at the spaceweather.com, spaceweathernews.com data. X-ray flux is flatlined as expected. We see a signal emerging in the phi angle here, but only in the last few hours. See if that continues. If it does, that should be the magnetic connection to the coronal hole. We are expecting a strong solar wind stream from that, which should be preceded by a small uptick in the solar wind density, and then finally a downtick in the wind density and an uptick in the wind speed, which you can see are at very low levels now. Solar wind density below 10 protons per cubic centimeter, and solar wind speed is looking like it's about 370 kilometers per second right now, very low. Magnetometer is looking weak. It only went up to about 115 yesterday or so. KP index has been at either 0 or 1 for the past 24 plus hours. So the cosmic ray human health alert continues. Here's your electron flux, flatlined to pegging at 0. I mean, really low levels in the ionosphere here. Obviously no charging hazards. And here's your F2 ionosphere layer. Which, by the way, if you weren't aware, solar energy kicking in here, solar energy coming out here. All right, let's move on to the earthquakes. Take a look at the last 8 hours. It's actually been a bit of a downtick. So we've got 4.2 in Canada, 4.3 in Afghanistan at depth. Afghanistan remains on alert for a 5. Turkey gets a 4.2. Indonesia gets a 4.8. New Zealand gets a 4.4. Tonga gets a 5.1. Now that's probably, I think that was alerted yesterday. Don't quote me on that. Probably a release of pressure there. Oh, and that Canadian earthquake, man, that's a rare one. It's a bit on the craton. That's an odd earthquake right there. All right, moving on. Let's look at some earth weather by using the windy.com app. All right, so we're looking at wind here. And oh my gosh, the wind is 130 miles per hour over Indiana. Jeez, oh whiz, out in the Atlantic, it's 135 miles an hour. Just kidding, folks. That's a jet stream. We're looking at an altitude of 9,000 meters, about 30,000 feet, because we want to look at the jet stream flow. Get rid of that. So let's move this around a minute and see where the jet stream's going. All right, looks pretty broken up. See kind of a break in it right here. And let's head to the east, where we know there's some crazy low pressure systems at work. And there it is, breaking apart again, right here. Great example right here. Near Norway, traveling almost perfectly north and south, the jet stream. Another crazy swirl there. This is called meridional jet stream flow. And this is associated with solar minimums, global cooling. Why? Because it's able to transfer really cold air really far south. I think the best example of it is this one over here. Look at that jet stream. Caused by a weakening magnetosphere. Now let's look at the pressure maps. Because we've got a bunch of anticyclones all over the planet. I'll just let that load. Okay, so now we're on pressure, and you can see that extremely powerful low pressure system that was affecting the eastern portion of the U.S. is now in the North Atlantic, and it's butting up against another giant low pressure system. And these are just funneling air straight down into the UK. I'm not sure the weather forecast there. Any UK viewers, please let us know. But look at the size of this anticyclone. For those of you who are not aware, an anticyclone is when we get, in the northern hemisphere, a clockwise rotation associated with high pressure zones and positive electric charge. That is one giant anticyclone right there, associated with dry conditions and high pressure. And we've got this anomalous low here, which is just causing a massive convergence. That's a global electric circuit at work. Now, why are we covering this? Global cooling, baby. Global cooling. It's a solar minimum, and it's the right time to be looking at it. So, let's look at some other information, because this is intimately related to the weather right above your head. Talking about the jet stream, we're going to leave links to these articles. And I just wanted to look at this diagram here to explain the difference between zonal and meridional flow. Normally, the jet stream at a solar maximum looks like the red line. And the way the jet stream currently looks is like the orange line. Meridional flow, much more efficient at transferring massive pressure gradients to and from the poles, which is why we get warm spikes in the poles and why we get cold spikes in the poles, but ultimately the cold wins, as it has for millions of years on our planet. Let's look at the U.S. Doppler radar. And there are your current conditions in the U.S. Got scattered showers basically all over the place. I'll let that play for a second. And let's look at the NASA GOES water vapor map to give you folks who are concerned about whether you're going to get showers or not a little bit of a concept of what's going on in the upper atmosphere. Let that play through. And going to zoom in on one small convergence zone there over Texas. Another prime indication of global electric circuit. You've got lines of water going this way, and then you've got lines of water here perpendicular to the mode of travel. Prime example of electrical influences in your atmosphere. And down here you got a bunch of almost grid-like patterns down here. They're not chemtrails. You could call them radio frequencies. Why does that matter? Well, because the global electric circuit pretty much runs your life. If you're not familiar with the global electric circuit, we'll be more than happy to leave a link to this diagram also. So, number one, you've got field-aligned currents coming in from the sun. Those split into, well, let's backtrack. We've got solar protons rolling in, and those solar protons are going to split into field-aligned currents. They're going to show up at the poles, and then become part of the ionosphere. After that happens, charge equalization wants to occur through this area, known as the atmosphere, which is a semiconductor. And anyway, galactic cosmic rays affect this, water vapor affects this, magnetic fields are caused by and affect this. The global electric circuit is responsible for your weather. In any case, we thank you for tuning in. We await a heavy coronal hole wind stream. And according to solarham.net, it's predicted for tomorrow and December 2nd to be a G-class geomagnetic storm. So we'll be keeping an eye out for that. No predictions here because I don't really understand the magnetic situation, but we'll be watching the telemetry and keeping you updated about if anything's going on with this active region rising and other data. Thanks, subscribers. Remember, when you're awaiting a coronal hole wind stream, don't drink. And if you drink, don't drive.